Hi, this is Daryl from the Technical Marketing Engineering team, and I'll be covering AOS-CX 10.12 update on IPv4 multicast VXLAN.
This is the agenda. I'll go through the overview, use cases, details and caveats, configuration, best practices, some troubleshooting, demo, and additional resources. Overview-wise, so before 10.12, PIM SSM was only supported for non-VXLAN networks, and IPv4 for layer 2, layer 3 multicast in the VXLAN overlay was only supported for single fabric EVPN VXLAN. What's new with 10.12? 10.12 now, we add support for PIM SSM in the VXLAN overlay. These are the platforms that are supported as VTAPs. So you can do both non-VXLAN and VXLAN with 10.12 or PIM SSM. There's a difference. And now, in addition to single fabric, we can also do multi-fabric for IPv4 multicast. But take note, it's only for routing. So basically only layer 3 between the different fabrics. These are the platforms that are supported as the border or border leader VTAPs. The normal VTAPs can be 6300, 6400, etc. But because multi-fabric is concerned about the border, we only state the border devices here. So the above new features will utilize IPv4 unicast in the underlay and support v4 multicast in the overlay. Use cases. This is the typical network topology with VTAPs and non-VTAPs. You have your access switches here connected to the source and receivers. Those are considered VTAPs. And you have your AG switches, your core switches here. Those are non-VTAPs. So I'll keep it simple. For the rest of the slides, I'll use a simplified view without the underlay. Because again, for the VXLAN network, we're mostly concerned about VTAPs. So just ignore all this. I show you the VXLAN tunnels for intra fabric VXLAN tunnels between the VTAPs here. We're using orange. And the main purpose is to show you the source and receiver. Right? They're connected to the EVPN VXLAN fabric. Because we want to focus on this fabric to support multicast traffic forwarding. So in the simplified view, I use a single switch icon for VTAPs. VSX logical VTAPs should also be used for high availability when applicable. For example, where it's a border, you should use VSX logical VTAPs. But if it's like an edge access VTAP, typically it's a VSF stack or just single 6400 chassis. Okay. So let's talk more about the PIM SSM in the VXLAN overlay. When would you want to use this? When you have VXLAN tunnels between the source and the receiver, and the receiver is aware of the specific source IP he wants to join. So here, this example, I have a receiver here. He wants to join this stream 232.10.10.10 from the specific source 21.113. He knows which source he wants to receive the multicast stream from. It's not 21.114, but he wants to join from 21.113 instead. This is the default SSM range 232/8, and a rendezvous point is not required for PIM SSM. So in this example, I show you single fabric EVPN VXLAN multicast. Let's move on to multi-fabric. Here you can see I have two fabrics, fabric 1 on the left, on AS number, fabric 2 on the right, a different AS number. And within the fabric, I have the orange intra-fabric VXLAN tunnels. Between the fabrics, I have the blue inter-fabric VXLAN tunnel. So all tunnels within the fabric will be terminated at the border, and they'll forward the traffic, multicast traffic, from the intra to the inter-fabric, again to the inter-fabric, so that the receiver can receive the multicast stream. And when would you want to use this multi-fabric? Is when the total number of VTAPs exceeds single fabric multicast EVPN scale. And that's 32. 32 fabrics, 32 VTAPs in this fabric. If you need to scale beyond 32 VTAPs, that's when you need multi-fabric. You need a second fabric for the next 32 VTAPs. So this multi-fabric will support both PIM SSM, where you have your specific source, and normal PIM sparse mode, and there's no specific source to join. So this receiver is interested in both SSM and non-SSM traffic. He can receive those multicast streams. Both layer 2 and layer 3 multicast is supported within the same fabric, but only layer 3 multicast, you need to route, and the source and receiver on different subnets is supported between fabrics. So only L3, only routing is supported between fabrics. It can be the same VRF, but need to be in different subnets. You can see here, my receiver is on the 20 subnet, my source is on the 21 subnet. Details and caveats. The CX multicast VXLAN implementation is proprietary, so all VTAPs need to be CX switches. You can actually do the interop on the border VTAP towards the non-VXLAN network. Here, you can just run normal PIM, sparse mode, or SSM, etc. And you can utilize VSX lags, ROPs, or point-to-point SVIs on the border towards the non-VXLAN network. So refer to 10.6 Multicast VXLAN TY for more details. We always recommend the BSRs and RP to be redundant, and they can exist in either the overlay or non-VXLAN network, or both. So this example, I have BSR RP1 on the non-VXLAN. The second one here is on the VTAP in the overlay for redundancy. So take note, PIM must be enabled in the overlay VRF and interfaces. So where do you enable PIM? You enable on the SVI facing your source, your receivers. So SVI 20 here, SVI 21 here, you enable PIM in that VRF. And you also enable PIM on the loopback. You create another loopback and you attach the VRF to it. That has to be PIM enabled on all VTAPs. So only distributed layer 3 gateways are supported between fabrics. So you can't use centralized gateway. That's not supported. So you can have SVI on multiple VTAPs with the same default gateway. That's what I mean by distributed layer 3 gateways. The 21 subnet, the gateway can exist in Fabric 1. The 20 subnet default gateway can exist in Fabric 2. Not supported. Centralized layer 3 gateways between fabrics. Layer 2 multicast, where the source and receiver on the same subnet between fabrics. You can only route between the fabrics. IPv6 as tunnel, as VXLAN tunnel source for both the single fabric and multi-fabric VXLAN features that I mentioned today. Right? You can't use IPv6 as the VXLAN tunnel source. It has to be an IPv4 tunnel source IP. Other caveats to be aware of. This command, dynamic VXLAN, tunnel bridging mode, IBGP, eBGP. This is typically used for layer 2 bridging traffic between the different fabrics. But since we do not support L2 between the fabrics, this command is used to identify a device as a border. When you put in this command, this will inform the multicast implementation that this is actually the border for the multicast fabric. It's just used to identify the VTAP as the multicast border. It doesn't actually bridge the L2 traffic. So it's mandatory, you need to add it in. Otherwise, you wouldn't know that this is the border. And okay, so let's see what happens when we only have layer 3 VNIs at the border VTAPs. Okay. We have layer 3 VNI neighbors between these two VTAPs in the same fabric. Between the different fabrics, same thing, we have PIM neighbors. Here from border 2 to VTAP 2, another set of PIM neighbors. So they're all on the same L3 VNI 1000, but you have different neighbors, right? They are directly connected through the overlay. The neighbors are not with the underlay network devices, it's through the overlay. They appear over the layer 3 VNI. Take note, the underlay loopback IP in the default VRF is shown as a PIM neighbor over this L3 VNI. So if you do a show IP PIM neighbor, you actually see the 33 IP as a neighbor over the layer 3 VNI. So this, if you only have the layer 3 VNI at the border, you do not want to span the L2 SVI or the L2 VNI over to the border, that's supported, right? No problem. Because we only want to do L3 between the fabrics. But let's say you want to span the L2 within the fabric. You have some devices here that are on the same VLAN 21. That's also supported. You can have both layer 3 and layer 2 VNIs at the border. You just have more PIM neighbors. So I have the normal L3 VNI here at the top. I also have the L2 VNI within the fabric. You see, I have neighbors both for the L3 VNI and the L2 VNI. So that is supported and valid as well. But you can't span the same L2 VNI across fabrics for now. Scale information. So this is single fabric, PIM SSM scale. You can see these are the VTAPs. 128 VLANs in a single fabric. The lower end platforms, 6300, 6400, they support 16 VRFs, while these support 32 VRFs. Right? 64 SVIs, IGMP, and they're typically the same except for the 8400 and MROS as well. So within the fabric, 32 VTAPs are supported. Let's look at multi-fabric. And specific to border VTAP, the main difference is at the border, there's the inter-fabric VTAP. So 32 within and 32 inter. They can peer to other fabrics. Configuration-wise, let's take a look. So let's start with VTAP 1 on the left. What to configure specific for this multicast. Right? The ones that are not in bold are typical VXLAN configuration. Right? Let's focus on the multicast portion. I have a normal loopback. This uses the VXLAN tunnel source. You can see source 1.33. That's in the default VRF. I also have another loopback here, 10. You attach it to the VRF. You enable PIM sparse enable on that back. On the SVI facing your source or receivers in that VRF, you also enable PIM sparse. And this VTAP 1 is also a BSR and RP, so I have additional config with the router PIM VRF specific to that VRF. You enable PIM SSM if required. You enable PIM, your RP, and the BSR. So, like I mentioned, you should have one or two devices that support the RP and BSR in the network for redundancy, right? But in this environment, I only show you one. So the rest of the VTAPs, they do not have this RP or BSR config. So let's look at the border. Next, border 1. The border should have this config, this line, so that it knows it's the border VTAP for multicast traffic. Same thing in the loopback and on the SVI, you enable PIM. Here you see I've routed PIM, VRF, VRF1. I only enable PIM and with SSM. There's no RP or BSR required. Just simpler. On border 2, same thing. To identify this VTAP as a border for multicast, you enable PIM sparse at the loopback and on the SVI if required. Same thing for router PIM VRF, enable PIM SSM if required. Now we have VTAP 2, very similar to VTAP 1, right? On the loopback, enable PIM. On the SVI, if there are receivers here, there should be IGMP as well. And you enable PIM on the SVI as well. Router PIM, VRF, VRF1, enable that, as well as PIM SSM if required. If this receiver is not interested in SSM traffic, like the 232.10.10.10, you do not need to enable PIM SSM. And there are additional config examples in the 10.12 multicast guide. You can see here the multiple, there are 4 here for both sparse mode and SSM. Best practices. So BSRs and RPs can exist in either the overlay or non-VXLAN network or both. Redundant BSRs and RPs are recommended for PIM sparse mode. And if there's no interest in PIM SSM, don't enable it, right? Otherwise, it's just additional config, loading your config file. Loopback in the VRF is required to establish PIM neighbors in the overlay. And it's not mandatory to only utilize PIM-SSM on the network. You can have a parallel PIM sparse mode deployment with the BSR-RPs for non-SSM ranges. So this network, I support both the PIM-SSM 232 range and the PIM-SM 239 range, the BSR and RP in the overlay. Best practice, but not specific to this new 10.12 features, but might impact them. Okay? So this was released in 10.10. So if you have source and BSRs were different, the RP are different, you need to configure this on this VTAP here to register the source correctly. That's new, so just a reminder. Other reminders, this command on the SVI. So this is required, again, this was released earlier, before 10.12. Just a reminder. So this allows the interface to be in the same multicast data path state on both VSX switches. So you really only need it on VSX border switches here, on the VX border, on the transit SVI. This is not on the SVI facing your receivers or sources. It's on the SVI, which is in between the VSX switches. It's only required when there's an L3 connection, a point-to-point or ROP to the non-VXLAN routed network with receivers. And this IP PIM sparse VSX virtual neighbor in the VSX, in the SVI, this is also not new. It was released back in 10.10, but should also be enabled, right? Because it might impact this new 10.12 feature. So you should enable this command on the SVI on VSX switches. This will allow the switch to process IGMP and PIM joins, regardless of its DR role. So required on all VSX VTAPs with SVIs with VSX lag. Another reminder. So we distribute local SVI. This is required when sources are connected to VSX switches and IGMP snooping is desired across the overlay network. If there are any VSX switches in the fabric, this command is mandatory on all VTAPs, even the standalone VTAPs here. So enable this command if you want to do IGMP snooping across the overlay network, across a single fabric. Troubleshooting. This is the recommended troubleshooting flow. Check unicast first, because if unicast doesn't work, multicast will not work. Check your PIM neighbors, make sure they're established. Check there's BSR and RP, they exist. Check that the IGMP joints are seen on the receiver. Check that the emeralds are seen. If all these are not seen, then troubleshoot further. So unicast, you can check the unicast routing table. Here you can see VTAP 1 has a route to 20.1120 host route. And on the receiver, this is 20.112. You see you can ping to the source 21.113. So unicast works, right? Just verify across your different fabrics this way. Take unicast first. PIM neighbors. So VTAP 1, you can see there's two neighbors. One neighbor is through the L2 VNI, VLAN 21, and the other neighbor is through the L3 VNI. So this VRF 1. You see the IP address is 1.38, which is loopback 0 on border 1. So on border 1, you can do the same command, show IP PIM neighbor all. Actually, 3 neighbors in this VRF now. I have the L2 VNI based on the SVI. So they both have 21.11254. That's the default gateway on VLAN on SVI 21. And L3 VNIs, you have one on the left. Border 1 has 2 neighbors in the L3 VNI. On the left, 1.33. Okay. And on the right, 1.36. The VNI is 1000. So it's not, again, it's not the loopback in the overlay that's seen as a neighbor, is loopback 0 that's seen as the neighbor. Just be aware. check the BSI and RP set exists on the VTAPs. So you do this on all the VTAPs. The border one, for example, you do show IP pin BSR all. You can see that 113, because we set this as the BSI and RP, you can see the BSR is correct. You should see the correct IP, the intended RP shown here, 1.113. So RP set, same thing. You want to check the RP set is correct. It's pointing to the correct VTAP. So here, 1.133 is the correct RP as well on all the different VTAPs. And on the receiver, you want to check that it does see the IGMP joins, the receiver. This is the PIM SSM join. You can see the reporter is this IP 20.112. Okay. He's interested in this group. And same thing. He's also interested, this reporter is also interested in 239.10.10.10. Finally, check the MRoutes. So on each VTAP you can check, just like Unicast. You can see here, this VTAP as a route for this SSM MRoute is true. It's incoming VLAN 21, and for the 239.10.10, same thing. It's from this source. Incoming is VLAN 21. On the border, we also see this two multicast groups. For the PIM SSM, you can see incoming is VLAN 21 to the L2 VNI, and it's forwarding out the L3 VNI. It's routing out to the border 2. Same for the 239 multicast stream. Incoming is L2 VNI, outgoing is the L3 VNI, border 2. So on border 2, you see these two routes. SSM, you see it's true. Where's the source? Who's the neighbor? Where's the incoming? It's the L3 VNI, and it's forwarding out the L2 VNI. Same for the 239 multicast stream, right? This is not SSM, so it's false here. Incoming is L2, outgoing. Incoming is L3 VNI, outgoing is L2 VNI towards VTAP 2. On VTAP 2, you can see it's incoming, but there's no outgoing because it's on the same VLAN. You can see outgoing is only on the border here. You just forward out VLAN 20. Okay, so let's move to the demo. I'll show you this, my setup, and I have both PIM SM and PIM SSM multicast stream functioning across multi-fabric. Lab here. This is 20.112. This is the receiver here. Let's check first Unicast. So it's trying to reach to 21.113, which is the source. So we have verified that Unicast works across multi-fabric. Next, let's look at the VTAPs. So I have VTAP 1 here. And that's here, this guy, connected to the source. What can we see? Let's check the PIM neighbors first. Here's a neighbor through the L2 VNI. He also has a neighbor through the L3 VNI 1.38, which is here. Okay. And let's look at the MRoute next. This source is sending multicast streams to both. It's sending out the source 21.113 is sending out these two streams. It's just incoming because there's no receiver requesting for it. There's no outgoing. Let's go to the border. Border 1, which is here. In this VRF, you can see he has a neighbor on the L2 VNI, which is VTAP 1. He also has neighbors to the L3 VNI 1.33 and 1.36, which is border 2 here. So when you check, you should see all your expected neighbors. You have your diagram, your topology a bit ready, right? So you can check. If your neighbors are not seen, that means there might be a configuration problem. Okay. So, but if you check the MRoute, you can see here as well, incoming. It's all through the L2 VNI. There's no outgoing, right? You see the two streams, but there's no outgoing. So on the border, 2 here. We see 3 neighbors. You should expect to see 3. One is through the L2 VNI VLAN 20, VTAP 2, and the other 2 should be its left and its right. The first one is through the L3 VNI 1.32. It's on the right. The other one is 1.38 or through the L3 VNI on the left. Neighbors are seen, but of course, no routes, no M routes, because there's no active multicast traffic. Finally, on VTAP 2, you can see 2 neighbors, one through the L2 VNI, one through the L3 VNI, and that's 1.36 is here. VTAP 2 sees the border 2 as its neighbor for both L2 and L3 VNI. No M routes as well, but it should have IGMP joins seen, or not seen, because there's no request as well. Right? So the receiver has not sent any request, so you will not see for those two streams. Okay, so now let's go to the receiver. Let's start. Okay, we're interested in joining 2 streams. Open network stream. First, we'll join the SSM, specific source, and the 232 range. Let's play. And we'll join. Okay, let's join this RTP session. Next, let's open up another stream to the fast mode session, the 239 range. Here, play that. Okay, and that also works. Right, so that works. Let's go back to our configs, our devices. Step 2. This is here again, the one that's connected to the receiver. Now we should see some IGMP joins. 232, 10, 10, 10. You can see the reporter is 20, 112. This receiver. And this is, right, and the source. This is the source that he's interested in joining for this group. Go down further, for 239, you can see the reporter is also 20, 112. We send a join for IGMP. We check the M route. You can see 4 entries. For the SSM range, you can see incoming 20, the L2 VNI and the L3 VNI. Because we just started this stream, we show both, but after some time, only the preferred one will be shown. So it takes time to show just the final state. So same thing for the 239 range, both will be shown. But you notice there's no outgoing interface because that's on the border. On this border 2, we'll show IPM route now. You can see 2 entries. SSM, right? You can see the source incoming through the L3 VNI from border 1. Outgoing is L2 VNI VLAN 20 towards VTAP 2. Same thing for the 239 range. You see incoming L3 VNI, outgoing is L2 VNI towards VTAP 2. Okay, so that's it for the feature demo portion. I hope you get a better understanding of both SSM and normal sparse mode across multi-fabric. Next, we also have another demo that's with scale. Okay. So in this demo, I have a VSX border here. I would like to show you we can indeed scale up to 32 intra-fabric VTAPs here. The border will appear to 32 intra-fabric within this AS number 100. So these VTAPs are on the 777 range. And this border can also appear to 32 other inter-fabric VTAPs. So these are in different AS numbers, AS1 to AS32. They're on the 444 range. Okay, let's take a look. First, let's look at the BGP neighbors on the VSX Primary. You can see here the neighbors. 444 range, different AS numbers. So we have 32 inter-fabric VTAPs here. And for the 7 range, that's on the same AS number. We also have 32, and they're all established. So the peering is up on the VSX Primary. So let's look at the VSX Secondary next for BGP neighbors. Same thing. You see 32 peers for inter-fabric VTAPs because these are different AS numbers. For the 7 range, we also see 32 of them in the same AS number. So they're all established as well. Next, let's look at the VXLAN tunnels on the primary. You see from 1 to 32, they're all operational. The tunnels are up, the red VRF. We also have on the 7, the intra, they're all operational as well. You see different VRF, there's a red and a blue. That's on the primary. All the VXLAN tunnels are operational. Secondary, same thing. You see operational for the ones on the 4 range, which are inter, operational. And for the 7 range, that's intra. So for both primary and secondary VXS switches, all the VXLAN tunnels are operational. Next, let's look at the PIM neighbors. So you can see here, for VRF red, I have 124 neighbors. On the secondary, for blue VRF, I have 3, and the red, I have 123. All up, all the neighbors are up. Emeralds next. So on the VSX Primary, emeralds. For the blue VRF, you can see it's about 1,500 emeralds. They're active. You see the other VRF soon. For the red VRF is 2,000 emeralds. So total, 3,500 emeralds are active on the border. We should see the same thing on the secondary. For VRF blue, 1,500 entries are active. Lots of emeralds you can see. On the other VRF, we should see 2,000 for the red VRF. So again, 3,500 emeralds are active on the border we have shown. Okay, so from a scale perspective, I hope it's better that you can visualize that the borders can indeed support both 32 intra and 32 inter-fabric VTAPs. Okay, with that, thanks.